Hello, grade 9 special mathematics class. 9 Bernoulli and 9 Briggs students. This time let us learn how to solve system of linear equations in two variables. What you should learn in this topic: use method of elimination to solve systems of linear equations in two variables. Graphically interpret the number of solutions of system of linear equations in two variables. Use systems of linear equations in two variables to model and solve real-life problems. So, the method of elimination. Now we will study the method of elimination to solve a system of linear equations in two variables. The key step in this method is to obtain for one of the variables coefficients that differ only in sign, so that adding the equations eliminates the variable. So in this case, in this system of linear equations given here, we have eliminated x variable, so that you just add y, 5y plus negative 2y, 3y, 7 plus negative 1, 6, and then by dividing the equations by 3, we have here y equals 2, which you can then back substitute into one of the original equations to solve for x. Right, let us solve for system of equation. Example number 1, 3x plus 2y equals 4, 5x minus 2y equals 8. So we can now instantly eliminate the variable y, because if you add this, the result is 0. So we'll just add 3x plus 5x, so we have 8x. 4 plus 8 equals 12. 8x equals 12, divide both sides by x, so 12 eighths is 3 halves. Okay, lowest term of 12 over 8 is 3 halves. Now to solve for y, substitute the value of x 3 halves in equation 1 or 2. Okay, let's choose equation 1. 3x plus 2y equals 4. Substitute x by 3 halves. This becomes 9 halves plus 2y equals 4. 4 minus 9 halves is, yes, negative 1/4. So therefore the solution is 3 halves negative 1/4. So substitute, to check, you can substitute the values of x and y in the two original equations. Yes, here for 3 halves in equation 1, 9 halves minus 1 half is 8 halves, so it's equal to 8. It means it's equal to 4. Dito naman 15 halves plus 1 half is 16 halves, so 8, correct. So to use the method of elimination to solve a system of two linear equations in x and y, perform the following steps. Number 1, obtain coefficients for x or y that differ only in sign by multiplying all terms of one or both equations by suitably chosen constants. Add equations to eliminate one variable, solve the resulting equation. Back substitute the value obtained in step 2 into either of the original equations and solve for the other variable. Check your solution in both of the original equations. Graphical interpretation of two variable systems. It is possible for any system of equations to have exactly one solution, two or more solutions, or no solution. So if a system of linear equations has two different solutions, then it must have infinite number of solutions. That means the lines coincide with each other. And to see why this is true, consider the following graphical interpretations of system of two linear equations in two variables. Okay. For a system of two linear equations in two variables, the number of solutions is one of the following. When there is exactly one solution, and the two lines intersect at one point. When there are infinitely many solutions, the two lines are coincident or identical. Okay, coincidental. But if there is no solution, the two lines are parallel. Of course, when two lines are parallel, they do not intersect. Therefore, there is no solution. A system of linear equations is consistent when it has at least one solution. Consistent, one solution. It is inconsistent when it has no solution. Alright. Consistent when it has one solution, inconsistent when it has no solution. Match each system of linear equations ABC with its graph in figure 7.10. Describe the number of solutions. Right. Okay. When there is no solution here, when they are parallel, they must have the same slope but different y-intercepts. Here, wait. It's hard. Okay. This is a solution. For A, the graph of system is a pair of parallel lines because, yes, in A, if we're going to solve here, the slope by slope-intercept form, y equals mx plus b, yan, dito na. They have the same slope. So that means they are parallel lines. And if they are parallel lines, it has no solution for A. But for B, the graph have one point of intersection, so the system has exactly one solution for B. So the system is consistent for B. How about for C? The C, in C, they are exactly identical. Okay, pareho ng equation if you simplify the two. So if they are identical, that means the lines have infinitely many points of intersection. So the system has infinitely many solutions. The system is consistent also. Let us now apply our knowledge in solving systems of linear equation. So at this point, we may be asking the question, how can I tell which application problems can be solved using a system of linear equations? The answer comes from the following considerations. Does the problem involve more than one unknown quantity? Are there two or more equations or conditions to be satisfied? So when one or both of these conditions are met, the appropriate mathematical model for the problem may be a system of linear equations. So let's have here an aviation problem. An airplane flying into headwind travels a 2,000-mile flying distance between Cleveland, Ohio and Fresno, California in 4 hours and 24 minutes. On the return flight, the same distance traveled in 4 hours. Find the airspeed of the plane and the speed of the wind, assuming that both remain constant. So the two unknown quantities are the speeds of the wind and the plane. If r sub 1 is the speed of the plane, r sub 2 is the speed of the wind, then r sub 1 minus r sub 2 is the speed of the wind, speed of the plane against the wind, minus, kasi against. Pag speed of the plane with the wind, plus naman, r sub 1 plus r sub 2. Right? It's the same as the downstream upstream problem. Pag downstream, minus. Pag upstream, pag downstream plus, pag upstream minus. So pag against the wind, r sub 1 minus r sub 2 plus pag with the wind, r sub 1 add. Yan. Original flight against the wind, so r sub 1 minus r sub 2. In the return flight, with the wind na siya, so r sub 1 plus r sub 2. So the formula here is distance equals rate times time. So for these two speeds, you obtain the following equations. 2,000 equals r sub 1 minus r sub 2 times 4 plus 24 over 60. So where did we get 2,000? Yun, 2,000 mile kasi yung distance niya. Tapos meron pang yan, 4 hours and 24 minutes. So 4 plus 24 over 60, yan yung minutes yan. So since we are trying to find the rate, find the airspeed of the plane and speed of the wind, assuming that both remain constant. So this is the formula. Dalawa pala yung formula. For yung against the wind, r sub 1 minus r sub 2, 4 plus 24 over 60 para sa with the wind, 2,000 equals r sub 1 plus r sub 2 equals 4, forming a system of linear equation. So let us simplify the two equations. For equation 1, yan, magiging 5,000 equals 11 r sub 1 minus 11 r sub 2. Yes. See, this will become 24 over 60 is divided by 12. 2 over 2 over 5. 2 over 5. 4 plus 2 over 5. 22 over 5. Yan. So, naging ganyan. Tapos, simplify. 5,000 equals 11 r sub 1. Dito naman, 4r. Divide both sides by 4. Which is 500. Or if you divide 2,000 by this, okay, magiging, yan, meron pang 11. So from here, we can now solve the systems of linear equation by multiplying equation 2 by 11 para makancel yung r sub 2. Yun, naging, okay. 5,000 for equation 1, 11 r sub 1 minus 11. 5,500, 11 r sub 1 plus 11 r sub 2 for equation 2. Okay, now cancel r sub 2. 22 r sub 1 equals 10,500 divided by 2. 22 both sides. Divide both sides by 22. Is 5,250 over 11. Okay. Or if you divide that, the equivalent decimal is 477.27 miles per hour. And that is the speed of the plane. About the speed of the wind. Ano lang, substitute mo lang. R sub 1, diba? R sub 2 is 500 minus R sub 1. So 500 minus this is equal to 250 over 11. 22.73 miles per hour. Speed of the wind. Speed of the plane. Yeah. Yeah. Bilis yung plane. Alright. So that ends our lesson on elimination method with a little bit of a problem application with system of linear equations. Bye.